This video is going to review solving systems of equation using elimination from algebra. Just like yesterday's, you're going to submit your notes at the end of today, so make sure you take the notes and then submit them when the video is over. So this is the third and final method we're going to go over to solving a systems of equation. First of all, again, still systems of equation. So two variables, two equations. This way, so we've done graphing, we did substitution, and now elimination. Elimination is also sometimes called addition because the goal here is to align the equations so the x's are in a line with the y's are in a line, and then the constants, and then change them in such a way that when you add the two equations together, one of the variables cancels out. So sometimes you don't need to change them. You can just line them up and add and they'll cancel out. Sometimes you do have to change one equation or change both so that one of the variables cancels out. After you do that, when you combine those equations, there'll only be one remaining variable. You'll solve for that one. And just like we did with substitution, you'll plug it back in. And you can plug it back into either of the original equations, or you can plug it into one you altered if that's easier. Just like with substitution, there are special cases. If everything cancels out, if all the variables cancel, what's left is a true statement, then it's all real numbers. And if it all cancels out and it's a false statement, then it's no solution. All right, let's write in. So example 1, the first thing, again, you want to identify is that the x's are lined up, the y's are lined up, and the constants are lined up, and they are. And then if I were to add as is, the goal would be to cancel out. So if I did that, this would be 3x and this would be 2y. So nothing's going to cancel out. So what I want to do is change either one or both of the equations so that one of the variables will cancel out. Meaning same variable or same coefficient on front, but opposite sign. So I have two choices here. One is I could multiply the bottom by a -2 and then the x's would cancel out. The other is multiply the bottom by 3, and then the y's will cancel out. The only reason I would lean towards the second one is there's no negative involved, and people make some interesting mistakes when there's negatives involved. So I would just rewrite that first equation so I can align them up. Distribute the 3, so it's 3x. Distribute the 3, so it's -3y. And then distribute the 3 all the way on the other side of the equal sign, so it's 27. Add these, and I get 5x. These cancel like they're supposed to, and I get 40. Sorry. And then divide both sides by 5, and x is 8. Now this time when you plug it back in, it's not as easy as substitution because you haven't solved one for one of the variables. So this time we simply just pick one of the equations from the beginning and plug it in. So if I pick the bottom, because it's less complicated, plug in the 8 for the x. 8 minus y equals 9, and then subtract the 8. -y equals 1, divide or multiply by -1, and y is -1. And then my solution is 8, -1. And just like every other system, I can check by plugging these back in and checking to make sure minus a -1, that would become plus, and giving you the 9. So you can check them to make sure it's a balanced equation. Example 2, still solving using elimination. This time, it's already aligned. The y's are aligned, the x, and it doesn't have to be x first, y second, as long as they're lined up. And then the constants. This time, all I have to do is add these. The y's, y plus y would be 2y, and negative x and positive x are going to cancel out. 10 plus 20 is 30. Divide both sides by 2. Y is 15. And then take and plug it back in. So if I plug it back into the bottom one, 15 plus x equals 20. Subtract the 15. And x is 5. Again, order x, then y, and there's the solution to your system. Example 3, solve using elimination again. This time, if I add as is, it doesn't cancel. And this time I can't just change one of them. If I multiply, if I'm trying to get rid of the x's, I have to multiply one by a -2 and the other by a +3, or +2, -3. Either way, those will cancel. Or I can focus on the y's because they are already opposite signs. I would say maybe that's a better bet. And I would cancel by multiplying the top by 5 and the bottom by 2. So the top, I would get 15x plus 10y equals 20. Don't forget to go all the way opposite, all the way across. And then 4x minus 10y equals negative 58. Add these together. I get 19x, positive 10y, and negative 10y cancel out, equals negative 38. Divide both sides by 19. X equals negative 2. Then take and plug back in. And again, it doesn't matter which one. If I wanted to grab the top, just because the 4 is smaller than the 29, I could do 3 times negative 2 plus 2y equals 4. Negative 6 plus 2y equals 4. Add the 6. 2y equals 10. Divide by 2. Y equals 5. Negative 2, positive 5. And last one, again, solve using elimination. This time, if I just add as is, I get 7x. These would cancel, equals 42. Divide both sides by 7, and I get x equals 6. Take and plug it back in. So if I were to plug it in here, 6 minus 5y equals 20. Subtract the 6. Negative 5y equals 15. Divide by negative 5. And y is negative 3. So we didn't see it happen in the notes, but remember the special cases. So if you had something like 2x minus 5y equals 10, and negative 2x plus 5y equals 10, when I add these cancel, and then add and I get 20. 0 doesn't equal 20, so this would be no solution. If I had 2x minus 5y equals 10 and negative 2x plus 5y equals negative 10, now these would cancel. I'd get 0 equals 0, and that one equals, so this would be all real numbers. So those are the two scenarios that you would have special cases for. That's it, guys. So submit these notes so you can get your easy classwork grade. And then use the remaining time to work on the algebra review, solving using elimination, assignment on big ideas. And remember, you have to show work for every question. Have an awesome day, guys. Have a great weekend. See you Monday.